Hello, students. My name is Mr. Steed, and you probably know that already, but welcome to virtual learning on Thursday, December 3rd? Yeah, I think that's right. So today we're going to be working on the second page of the packet that you received that last day before everyone went home. So it would be this page right here. So graphing lines from an equation. So this is something we have done before, as is most of the things you're going to see these first few days of online learning. So I'm going to zoom in just a little bit. So basically, we want to graph lines, and we want to be able to graph lines that are given in any type of equation. So it can be in slope-intercept form, or like some of these other ones that are in standard form. Okay, I'm going to show you a couple different ways to graph these. But first off, when these are in slope-intercept form, the easiest way is going to be to graph them using slope and their y-intercept. You can still make a t-chart or a t-table, but we really want to get away from that because it's much quicker to graph them with slope and y-intercept. So when we look at this equation, we have to remember the slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so we can look at this first equation. We can see the slope is 3/4 and the y-intercept is 1. So what we're going to want to do is we want to start by plotting the y-intercept because the slope tells us where to go from a starting point. So we need to know where to start. So the y-intercept tells us to start at 0, 1. Okay, we don't want to start here at 1, 0. That would be the x-intercept, which is sometimes a mistake students make. So we want to start here, and then since our slope is 3/4, I like to think of that as a rise, a rise of 3 and a run of 4. So from this point here, we're going to rise 3, 1, 2, 3, run 4, put a dot. 1, 2, 3, run 4. Now we don't have a lot of room to graph any more points. We can go backwards and we can go down 3 and to the left 4. And then we're just going to take our straight edge and connect those dots. And that's all there is to it. And there's our nice little line. You could do the same thing if you made a t-chart. But what you're going to get is you're going to get a whole bunch of fractional coordinates until you get to this point, or if you went backwards and got to that point. So using slope and y-intercept is going to be a lot more efficient. Okay, so let's do one more like that. This next one, now the slope of this one's not a fraction. I like to think of it as -3 over 1. So our slope is -3, which really has a 1 right there. And then the y-intercept is 1 again. So we're going to start at the y-intercept at 0, 1. And our slope is -3 over 1. So that means we want to go down 3. So 1, 2, 3, and then 1 to the right. And then down 3, 1, 2, 3, 1 to the right. Now some students will want to go down 3 and then to the left, and then down 3 and to the left. But if you notice, if you do that, you're creating a line that is a positive slope. Okay, so we don't want to do that. We know our slope is negative. So there's our 3 points. And we're going to just take a straight edge and connect those. And that would be our line. Okay, so that is how you graph lines in slope-intercept form. Let's take a look at a couple that are in standard form. So here's the first example, x minus y equals -3. All right, so I'm going to just rewrite that over here like this. There's 2 ways to graph this, okay? One way is to find the slope and the y-intercept, which is what I'm going to show you right now. And another way is to just make a t-chart and look for the x and the y-intercepts. And I can show you that too. So let's just put this into slope-intercept form. So what we're going to want to do is we want to subtract x from both sides of this equation. Okay, x minus x is 0. So this would be -y or -1y equals -3 minus x. All right, so now we got to get rid of this -1. Okay, so I'm going to divide everything by -1. And I get y equals -3 divided by -1 is +3. And then a negative x divided by negative 1 is positive x, or positive 1x. So our slope is 1, and our y-intercept is 3. Slope is 1, y-intercept is 3. Okay? And the slope of 1, you really want to think of that as a 1 over 1, so that will help you with your rise and run. So we're going to start at 3, then we're going to go up 1, 1 to the right, up 1, 1 to the right, up 1, 1 to the right. So that's what a slope of 1 would look like. Okay? So that's how you can graph it by converting it into slope-intercept form. Now, before I connect these, I want to show you a different way to graph this same equation. Okay? So you're going to make a little table. And in my students, we watched a video and the guy referred to it as a baby table because it's like a small little table. And all you're going to do is you're going to plug a 0 in for x and a 0 in for y and solve the equation. Okay, so when I look at this equation, if x was 0, that means there's no x. So I'm just going to cover that up, and I'm just solving this equation. Negative y equals negative 3. Okay, so y would have to be 3, because negative 3 equals negative 3. Now, when y is 0, that means it's going to be x minus 0. So that whole minus y part is gone, and I'm just solving this equation. X equals negative 3. Well, that's pretty simple. That means x is negative 3. So we're just going to plot those points. 0, 3, boom. Negative 3, 0, boom. It's on the same line, as you'll see when I connect them. So if you do it with a baby table or with a small table, all you are going to do is need to connect the two intercepts. It's the same line no matter what way you do it. So at this point, I'm going to do one more example, and then I'll show you the answers to the other ones real quick, and you can check them. So let's do one more standard form example. Let's look at number 4, all right? So I'm going to show you how to put this into slope-intercept form. X plus 3y equals 6. Okay, so we're going to subtract x from both sides, and you get 3y equals 6 minus x, and then divide everything by 3. So it's y equals 2 minus 1/3 x. It's getting kind of small there. So the slope is negative 1/3, and the y-intercept is 2. So that means I start here, and I'm going to go down 1 over 3, down 1 over 3 like that. Okay. All right, I'm going to show you the other way too to graph it, which is by making a small table. So you make a small little table, x and y. You're going to plug a 0 in for x and a 0 in for y into this original equation. So if x is 0, the x goes away, and I have to solve that simple equation. 3 times y equals 6. Well, divide both sides by 3. Y is 2. 3 times 2 is 6. So 0, 2, which you already know is right there. And then let's say y was 0. Well, that means 3 times 0, so that whole term would cancel out. So x plus nothing equals 6. That means x equals 6, which is this point right there. So we connect those dots. And again, you don't need to do it both ways. Just pick whichever way that you choose, either with a little table or putting it into slope-intercept form. Okay, so right now you'd want to pause the video, and I will reveal the answers to you in a few seconds, and you can see if you get the last two right. All right, thanks.
A few moments later.
All right, welcome back to the video. So for number 5, the slope would be negative 4/5, and the y-intercept would be negative 1. So you start at negative 1, and you go down 4 over 5, and that's your graph right there. Now number 6, you start by either putting it into slope-intercept form or making a table. So in slope-intercept form, you get a slope of 1/2 and a y-intercept of 2. So you start at 2, and then you go up 1 over 2, up 1 over 2, and graph it. Or you can make a table and plot the point 0, 2, and negative 4, 0. Well, that concludes our short lesson and review on graphing equations or graphing lines from equations. Thank you. Have a great day.